guess what? Multiplying fractions is Module 4. Did we skip Module 4?
No.
Yes, we did. I taught you how to multiply a fraction times a whole number. That looks a little bit, oh, let me calibrate this. Four fifths times 5. Let's try that one, okay? Abdiel, tell me how to do this.
Multiply 5 times 4, 20 fifths, and then 20 minus 5 equals
20 divided by 5 equals 4, okay? So do you remember that from the sprint the other day?
Yes.
This is a little different. So do you remember, boys and girls, that almost everything we do in math, we start with a visual? So I'm going to show you what the visual looked like in Module 4. You can practice one in a minute. I'm just going to have you do one, okay? So 1/3 of 4 fifths means the same thing as 1/3 times 4 fifths. So when I multiply things, I combine them, don't I? Okay? So I'm going to show you what this looks like with a visual or a model. You do not have to draw this. So 1/3 would look like this. Dara, can you get the door, please? And I'm going to change the color of my pen just so you can see. 4 fifths. So here's 5 equal parts. And I'm going to shade 4 of them, but I'm going to go opposite direction with my lines. Just watch. And this is how Module 4 starts out, teaching multiplication of fractions. So the answer is going to be this area where there are x's. So it's going to be 4, and then, ooh, I forgot to write 4 fifths on the side. What's my total here? Abdiel, what's my total here? How many boxes altogether?
4 fifths? Wait.
How many boxes did I make? 1, 2, 3, 4, 5, 6. How many boxes did I make?
3,
3, 6, 9, 12.
18.
So 4 out of 15 is double shaded. Do you see that? Okay. So 4 out of 15 is my answer. Is there an easier way to get that answer than drawing this rectangle right here and doing all that shading? Emily?
You look at the bottom numbers, like 3 and 5, and multiply.
So you multiply the numerators and you multiply the denominators. That's correct. That's how you multiply fractions. Okay? So let's take a look at the next one over here. 2/3 of 4 fifths is the same as 2/3 times 4 fifths. Okay? So we could show it on a tape diagram, but we're not going to. Okay? We could show it on an area model, just for the fun of it. Or we could just multiply straight across. What do you think, boys and girls? When I say multiply straight across, do you know what I mean now?
Yes.
Okay. Now, 8 is not divisible by 5 or 3, and 15 is not divisible by 2 or 4. So that's simplified. Okay? Let's go look at the next ones. So 3 fifths of 2/3. 3 times 2 is what?
6.
5 times 3 is?
15.
That can be simplified. Try and do it quietly to yourself and see if you can figure out what to divide it by. You can't use 2. George A., what do you think?
3.
Divide it by 3. So 6 divided by 3?
2.
15 divided by
5.
So I'm going to put 2 fifths down here. Okay, the next one's similar. You're going to multiply it, then you have to simplify it. I'm not going to help you simplify it. Let's see if you can do it on your own. You can't divide them both by 2. You can't divide them both by 3. Just keep going. See if you can figure out what you can divide them by. Euridia,
3/8.
what did you divide by?
5.
5. 15 divided by 5 is 3. 40 divided by 5 is,
8.
is she correct?
Yes.
All right, fist to 5 on multiplying fractions. Lo and behold, we can learn something in a couple minutes, can't we?
Yes.
They're very simple. Okay, let's take a look at review of area. How's area different from volume?
It doesn't, it's just length times width.
It's length times width, so we only have 2 measurements, don't we? Okay, so length times width. Now, Cameron was the one that came up with this. He said, oh, I get it, Mrs. Lewis. When I'm just multiplying 2 things, then I put the little 2 there. And when I'm multiplying length times width times height, that's 3 things, so I put the little 3 there. I never thought of it that way. I was thinking 2-dimensional figures and 3-dimensional figures, okay? Or squared and cubed. But Cameron's idea works, doesn't it?
Yeah.
Okay, so here's what I know. I know that a square is going to be the same, okay? So what's 10 times 10? Let's put it in the middle when we can. So I have 2 measurements that I multiplied. My label is centimeters squared, okay? All right, 13 times 3.
39.
Okay, how'd you get it so fast? Did you think about this?
Yeah.
Or did you think about this?
Yeah.
One of those 2 ways, okay? So 39 what?
Centimeters.
Uh-oh.
Feet.
Feet squared. Good. Okay. Beverly, remind me the trick for multiplying 20 times 9.
Oh, I know.
I know, but I asked Beverly to help me. Can I give you a hand? Good. So 9 times 2. What do I do about that 0 though? I have to put it back on. Good. That's a review of module 1.
Oh, it's meters.
Oh, it's meters? Well, hey, I think it's a mistake. So either write meters or centimeters. I don't know which one it is. But it's one of those 2. Okay, you can change whichever one you want. Okay, 14 times 4. Think about that. Don't shout it out. So there's a couple ways to do it. You can visualize 4 14s. Or you can visualize 14 times 4. Or you might already know the answer. What's the answer?
56.
56 inches squared. Now I keep going back and I keep looking to see if I put a 2 instead of a 3. Because I'm so used to putting a 3. So this would be 20 inches times 20 inches. What's the answer?
400
400
inches.
square inches. Square inches. It's very important. So 13 times 8.
104.
Would you like to hear a couple ways the kids did it without actually writing down 13 times 8 standard algorithm? Micah said, Mrs. Lewis, you could just do 12 times 8, which is 96, and then add 8. Is that 104?
Yes.
Okay, here's what Hunter Williams said. Mrs. Lewis, you could just do, you could do 10 times 8, which is 80, and 3 times 8, which is 24, and that equals 104. I like their thinking. George, how did you do it so fast? In your head, probably? I know. Okay, so let's go on to the next page. How's volume different than area?
It's three times.
There's 3 dimensions, length times width times height. There's 3 measurements. So there's a couple ways I could figure this volume. I could just count all the cubes on top and double it and do the layers like we have been. Or I could do this. 3 times 2 times 2. It's up to you, but I want you to figure the volume of all of these, and then I'm going to pull sticks for you to come up and write it down. All right, so check your answers with the answers up here. All right, let's look at the application problem. I'm going to read this, then you're going to talk about it with your table group. Karen says, and don't say the answer if you figure out why, okay? Karen says that the volume of this prism is 5 centimeters cubed and that she calculated it by adding the sides together. Give the correct volume of this prism and explain Karen's error. Okay, discuss it with your table group. So table 5. What did you guys discuss?
We discussed that she got 5 because that her answer was wrong because she added to the.
What should she have done
When
instead of
got
that?
4, she added 1.
She should have multiplied. Okay, so Karen added instead of multiplying, I think. Karen added instead of multiplying. So the answer should be, what should the answer be? 4 cubic centimeters. Okay, you can answer that question however you want. You don't have to use my sentence. I just wrote it like that. Okay? All right, let's start the lesson. All right, this right here is a review. I want to do it. It's not going to take us very long, okay? We're going to use multiplication to figure out the layers and the volume. So what I want you to do right now is this. Put a multiplication sign there. Okay, so we have the layers of the earth. Remember, I taught you to just label that by putting E's there. We have layers of bread. And this layer is what we call, what are we calling that? Subway sandwich. Okay. So layers of the earth, how many lines do I need?
3.
Okay, let's do that now. And layers of bread?
2.
Good. Okay. And Subway sandwich.
3.
What?
1.
1. Okay. So now what we have to do is figure out how many are in each layer. So if I'm trying to figure out layers of the earth, I'm going to look at this top layer right here. How many cubes is that? 6. So I've got 6 cubes times 4 layers equals 24 cubic centimeters. Did you notice these two are switched around today? There's a reason. Okay, the next one. To figure out layers of bread, I count these cubes right here. So 4 plus 4, what is it? So 8 cubes, how many layers?
3.
3 layers. 24 cubic centimeters. Good. The next one, I count all the cubes in the front. I'm guessing it's 12. Is that 12?
Yeah.
So 12 cubes in each layer. There are 2 layers, and it's 24 cubic centimeters. Now, here's the really cool thing about this. This measurement right here is actually 2 measurements combined. This 6 is actually 3 times 2. Okay? This 8 is actually 4 times 2. Or 2 times 4, right? The 12 is actually 4 groups of 3 or 3 groups of 4. Okay? So this has 3 measurements. We're just doing one set of measurements in our head. That's the lesson today. We're going to figure volume by just doing one of the faces times the other number. So let's take a look at it. Here's the first one. It says, if 1 square unit is the area, that's a pretty important word right there, of one cube's face, and there are 6 cubes that make up this face, what is the area of this face? Write a number sentence to show the area. Be sure to include the units. Okay, so they just told us that there are 6 cubes that make up this face. So we're just talking the top of it. Just visualize the top of it. That's the area of the top. The area of the top is 3 centimeters times 2 centimeters equals 6 centimeters squared. Miguel's right, it's squared. How do I know it's area?
Because it's only 2 measurements.
It says it right here.
Because you're only
Doesn't
adding
it?
2 things.
And I'm doing a length and a width.
Yeah.
Okay? All right, let's go on to the next one. It's going to be a different face. So what we're going to do is we are going to figure out the area of this face. This looks like books on a bookshelf to me, does it to you? Yeah. So the area of the face with the arrow, multiplication sentence for that. Should I pull some sticks? How about Cheney?
So you're going to do 8.
Okay, that's the total.
4 times 2.
So I can do 4 centimeters
Times 2 centimeters.
times 2 centimeters, and the area equals 8 centimeters squared. Okay. We're going to do one more face. Now let's look at this last decomposition. Find the area of the front face. It's a little harder to find. Tell which dimension shows the layers and work with your, we're going to say table, to write an expression to find the volume. Turn and talk. So before you do anything else, talk to your table group about what you need to do here. Okay? Table 1. What did you discuss?
3 times 4.
Okay, 3 times 4 is what?
12.
12. It's the area of the face, correct?
Yeah.
Okay, so should I write 3 times 4?
Yeah.
3 centimeters times 4 centimeters equals 12 centimeters squared. Now how can I use that to find the volume?
Multiply it by 2.
Okay, so the measurement I haven't used yet. Now watch how I'm going to write it, because this is pretty important and I want you to write it down. The measurement I haven't used yet is 2. So I'm going to write 12 centimeters squared times 2 centimeters equals
24.
24 centimeters cubed.
Oh.
So this is 2 measurements, isn't it?
Yes.
We could have done it in our head. So we have to square it. So this is 2, 3, and that equals 3. Okay? So do you know what this is teaching you today? That you can take the area of one face times the other measurement to get your volume. Okay? All right, let's see what the next one is. Record the dimensions of this prism. What do you think record the dimensions mean?
Write it
Like,
down.
write down the height, the width, and the
Okay,
length.
okay, we got that. We don't know what the unit is, so I'm just going to say units. Have it be a U. Okay? What's different about this prism?
It's a little bit, no, never mind.
Well, I mean, didn't they fill in the cubes for us? Yeah. So we aren't seeing just layers and measurements, are we? We're actually seeing cubes. How would you find this volume? Talk to your table group about it. So on this one, table 2. You get to help me. Table 2, what do you think?
3 times 3.
Okay. What? Do you want to do that in your head or do you want to write it down?
Yeah, like do it in your head.
Okay, so what's 3 times 3?
9
9 units squared.
times
Stop.
2
Times 2 units equals 18 units
3.
cubed. Good. Okay. Did anybody do 6 times 3? Because
Yes.
that's what I was thinking of.
I did 2
Okay.
times 3 and then
So-
3. Yeah.
So, okay. So here's what. Table 2 used the measurements on the outside. I used the visual of the cubes on the inside. Is either one of them more correct than the other? No, it's just 2 different ways to do it. Okay, let's see what we have next. All right, I want to start on this because it's part 2. So I want to start on part 2 on Monday, and I'll continue recording then. Okay?